Hello everybody, this is Carol speaking. Welcome to our PolyWorks webinar. Today we're talking about how to expand your reverse engineering toolbox using PolyWorks Inspector. So a little bit of thinking outside the box here. Let's welcome Todd Anderson as he is our presenter today. Todd is a member of the technical support group. If you have any questions during the webinar, please use the questions panel. I will be monitoring the questions throughout the webinar. We will have a short Q&A session at the end, and if we don't have time to answer all of the questions, we will get back to you by email. We are recording this webinar, so it will be available for later viewing. Todd, it's all yours.
Thank you, Carol. So today, I want to go through and show you a different way that we can go through and do reverse engineering, but instead of doing an inspection using IMInspect, we're going to use IMInspect to do reverse engineering. I have a polygonal model of a crankshaft, and this crankshaft is very prismatic as far as all of the surfaces go and the shapes that we see. One of the things that we can do is we can use the surface-based features inside of Inspect to go through and recreate this model. And using those surfaces, we can export them out to a CAD-based or a CAM software. So from here, we can go through and launch our command on extracting primitives from polygonal models. And as we go through, we are asked to select elements on the model. Now, when I click on this, the software is going through and it's analyzing the entire model itself and looking at the curvature that it sees. As soon as it's analyzed everything and segmented it out, it will now go through and look at my selection. So the selection that I have on the left of my cursor there, you can see that they're dark green points. This has gone through from that selection, and in this auto create or auto extract mode, it's seeing that from that selection there's a cylinder, or excuse me, there's a cone there. And it's also gone through and propagated that cone to the associated elements that are surrounding it. So all the little light green points are the surface that are close enough to that, and these are what would be used to fit that particular feature. All I need to do is a quick right click and accept that, and I would have a cone. Now, I can also scroll inside of here and use the mouse wheel to make my selection larger or smaller. So rolling it down a little bit smaller, it will allow me to come through and select, say, the inside here, and as it does, it sees that as a cylinder. So I can quickly go through and select on items through here, and as I'm doing that, you'll see that every time I select a certain region, a different feature is highlighted. So I'll do a cylinder, I can just continue and just right-click after each one if I'm happy with it, and I have a lot of cylinders. Sometimes we may have a cylinder, but it's not completely connected. So in this case, you can see that I've got a round portion up here at the top and round at the bottom, but it's been cut off on the sides. I do want to have the same surface, cylindrical surface there at the top and the bottom. In this case, the software will allow me to go through, and instead of just using one selection, I can use multiple selections. So maybe what I'll do is I'll rotate it around here, pull my mouse wheel up a little bit, and select. And we can see that as soon as that selection is made, the software has gone through and it's fit a cylinder, but I'm not seeing really many points up here where that's being associated and fit to. So even though it is a cylinder, I want to add some more into that and have it refit to the top. So as soon as I click, you can see that those points are added in, the cylinder's adjusted, and it's separated by that flat. Again, I can confirm or I can right-click, and that would allow me to go through and create something along those lines as far as the cylinder that's disconnected. We can also go through with the multiple selection on. We can also have items that are completely separate. So what I would like to do is maybe create a plane from using this flat surface and this flat surface, or sections of the polygonal model, by coming through and clicking on one, if I click on the second one, you can see how the selection has grown, and it would create one for one in that region. I can accept that, and now I have a plane that runs between both of them. When we're in the automatic mode here, this is going through and it's analyzing everything that we had picked initially, so, and the curvature that was picked. So when I continue and go on throughout the rest of the model, it will again create those particular features. So in this case, we're going to come through and create some planes running towards the front. So we'll click here, and you may have to click over here. Sometimes the surface is flat. Sometimes there might be a little bit of noise inside of there. If that's the case, and what we're seeing right here is we see this is starting to form a cylinder, we can actually go through and restrict the software to say, you know what, I want to just create a plane from these multiple selections. And instead of using the automatic, we can do that. Again, we can right-click and go through and continue adding more in. So with multiple selections, we can go through and fit those certain items through there. Now, if you want to delete items that or selections of elements, you can middle-click. And what that will do is that will delete each individual one as we go back. So if I zoom in and I middle-click one more time, it takes me back to the beginning. If I were to come through and say do a selection right here where I can refine it a little bit more, that gives me something more along the lines of what I was looking for, and we're going to go ahead and select that. Now, the region that we have down through here on this step down on the shaft, there is what I would say there's a flat through here. However, the part that we scanned was damaged, and we can't quite use this function to go through and create a plane. So what we'll do is go back to the basics, and we'll just go through and create a feature using a plane feature, just using the fit to elements command. So by coming through and using that, it's as simple as going through and having us select the areas that we want. I can even drag down through here, and we'll say fit a plane. I've got a plane there, and we'll pop it back over here to the opposite side. Now, I'm not worried about this plane being perfectly perpendicular to, say, these cylinders or parallel to the existing ones. I just want to make sure that I have the plane fitted to those points. So this allows me to go through and look at the model itself and say, okay, what happens if I hide the polygonal model? And we look, we can see that we've got a lot of our features through here. Looks like we might be missing a couple planes, and we can add them in here as we go. And those planes will be these ones that are on this outside lobe. So let's click here, create a plane, and we'll get this other side right here. Okay, so we've got these planes and cylinders, and they've all been created, and they've been fit to the polygonal model. Now, the polygonal model isn't exactly perfect. There's a slight change in deviations between, say, this diameter of cylinder and this one. They could both be the same diameter. However, when we fit them, the axes aren't initially, say, coaxial to each other. Well, there's another portion of the software that will allow us to go through and make some changes or add some design intent back into these features that we've created. Those commands are located under the measure features command, and what we're going to look at is the make coaxial, make parallel, and if we needed to, we could use the make perpendicular. So what these commands will do is they will allow us to go through and reorient the features that were fit to the model and make them related to each other or a certain constraint. So let me go through and hide everything. I'm going to turn my cylinders back on. So let's say 1, 2, 3, and 4. So I've turned all of these cylinders back on. I'm going to go ahead and select them and come up and say measure, features, make coaxial. Well, the command will pop into place, and it's going to ask me, okay, you've selected all 4 of these. Would you like to use one of them to be primary? So would you like to choose one of these cylinders? So let's say cylinder number 4. We're going to keep that in place and not modify it. But what we'll do is we'll take all the other cylinders and we will make them coaxial to that particular axis of cylinder 4, and we will refit to the polygonal model. So in this case, for a primary feature, what I'm going to do with this is I'm going to go through and select cylinder number 4, and we'll say fit. And now all of these are coaxial. How we can tell with this is, you'll look at the bottom of the feature tree, you'll see that the software has gone through and created a copy of the cylinders themselves, and you'll see that there's a note out to the side that says they're coaxial. They're all dependent features, which means they were created from the initial features that we fit inside. However, the copy was made and refit, and they were made coaxial to cylinder number 4. So depending on the number of features you have in the tree, as you're going through and making things, say, coaxial or parallel, your tree can actually grow in size, and it might be a little bit too much to handle as far as organizations go. So instead of us going through and creating dependencies, what we can do is we can actually turn that option off. So I'm going to say Tools, Options. I'm going to come into Objects, and I'm going to go down to Features. Inside, by default, we have Create Dependencies mode checked. I'm going to uncheck that, apply, and click OK. And let me go back in, and I'm going to delete those 4 cylinders that were coaxial. And let's run this again. So in this case, what I'm going to do is let's grab cylinders 4 and cylinder 2. So 4 and 2, and we'll say Features, Make Coaxial. In this case, I just want these 2 to be coaxial to each other. I can come in and say cylinder 4, make cylinder 2 coaxial to that, and what happens is the object itself, and then the feature in the tree, cylinder number 2 has just been refit. So it's basically overwritten from the original one. The other options that we have inside here that we can go through and do is I'm going to take cylinder 1 and 3, and instead of us going through and saying, okay, I want to use a primary feature, in this case I'm going to say none. What happens with this is the 2 cylinders themselves, an average axis will be created, and those cylinders will be refit to the model, but they'll both share the same axis. So those 2 would be coaxial to each other, but it's done on an average. So we have the power to go through, and we're able to add more controls or design intent back into our features that we fit to, say, this imperfect model. Let's look at the planes now. So if I turn on these planes and we come back to them, we don't need 7 and 8. Let's go back through and we're going to look at planes 5 and 6 and plane number 4. So earlier, those 2 planes that I said I'm not going to worry if they were orthogonal or if they were parallel to anything, here's where I can come back in and say, you know what, all of these planes that I've created through here, and we don't want plane number 1, so we're going to unselect that. Let's grab these. And for this, we're going to go through and we're going to make them parallel. Again, you can have a primary feature for that, or we could have gone through and done an average. Now for this, I'm going to use plane number 4 as my primary. They fit, and now all of my features as far as planes are parallel to each other. They have been gone back and refit to the initial polygonal model, and we're ready to continue on. So if I turn all my features back on and I hide my model, we can see that, hey, this looks pretty close to being exactly what we have. Now, there's one slight discrepancy here, is they're not joining up. So everything is running a little bit short as far as they were fit. This is where we would actually use, say, a CAD software or a downstream software where they would have some extend and trim functions inside of them for us to go back through and tidy up the model. Now, one of the things that can happen, though, in CAD is each one of those commands, when we want to extend, say, a surface through here, sometimes the software will only limit us to extending one edge at one time, or it may just let us say, I'll only extend one body. So as you're building your feature tree, you would have a lot of extend functions as they're going through and/or a lot of trim functions. One of the nice things I like to do inside the software is we have the ability to extend and, say, what we call shrink the boundaries of each one of these surfaces or surface features here. So if I select all of these planes and I right-click and say Edit, I have a grow and shrink command. So with the grow and shrink command inside of here, I can tell it to go through and say, take all of your trimmed boundaries and let's extend them out and grow them by 10 millimeters. If we wanted to shrink them all back, we could come back in and say, let's shrink it back by 2, and everything's done in one click. Now, I can also come back with the command still open and go and select, say, all the axial base, so my cones and my cylinders through here, and I can also hit the apply button for them as well as shrink them back if I need to. Now, I've got all of this set up. All I would need to do is maybe use a trim function in a downside command. But before we go and export all of these out, which is as simple as just right-click and say export these features, one of the things that we tend to forget is our coordinate system. So if we come back and look, our coordinate system is where our digitizing device was down through here. We might want to use a local coordinate system relative to the part inside of CAD. So when we've got all these features created, it's easy to come back through and simply just go on the screen and start to select your features. So maybe we'll use that plane, say this cylinder, and I'll use this plane out here for a direction where I can come through and create a local coordinate system. And now when I export this out, that would be in that local coordinate system and take that into CAD. So from here, it's just a simple export this out and say send this out as an IGES. Now, I've already done this, and I've brought this into SolidWorks. So let me roll this back in SolidWorks and take this back to the point where we have all the surfaces brought in. So when all of the surfaces are brought in, we could use something like this trim command. And you can see that all these outlines are here where the parts were, the surfaces when they were brought in were extended beyond, we're able to trim them back. And also sometimes the CAD software may have a little checkbox that says, after you've gone through and trimmed all these, go ahead and create a solid model. So when this is done, we actually have a solid model now that we can go through and use functions like maybe I'll put a chamfer out here on the end, and or with the also the very end, I'll go in and put an M3 flathead screw cutout inside. So I've got all of that set in. Now, how good of a job or did we do when we ran through and did the reverse engineering and brought it in here to do the trim? Let's save this out as an IGES, and we'll call this, say, Todd 1. And let's make sure that we have it as IGES. Todd 1 IGES, save it to my desktop. And then we'll go back into PolyWorks, hide all our features, and import this back in. So we'll say Todd 1. And lo and behold, there is our CAD model all trimmed up. Let's do a quick color map. And let's put a little lower deviation for our search zone. So between 0 and 1, we actually have a pretty good job. So this is a quick way we can go through and we can do reverse engineering just using inspection. And for something like this, you'll notice I have this entire model is completely prismatic. I've only done a section of it just for time. However, this can be used in combination with other more complex reverse engineering jobs. Let's say you have a piece of plastic or plastic molding that on one side you have a lot of prismatic shapes versus the opposite side is full of free-form shapes. You could go through and do partial portion of the model inside of IM Inspect quickly, let's say the prismatic side, send that into CAD, take the opposite side where it's free-form, quickly use the surfacing tools and edit, and then send that into CAD and you have a model very quickly. Or you can go through and do all your prismatic shapes and use the sketching command as well. So this is just another quick tool or a quick way that we can use the tools that we have inside of here to do reverse engineering. In this case, we just used Inspect. So with that, I want to send this over to Carol and see if she has any questions.
Yes, we do have some questions that are coming in. So I'll start with the first one. So when you use the grow and shrink command, did it make a difference on the diameters of the cylinders? Did they get bigger or anything?
Okay, so the question was, when we used the grow and shrink command to make the cylinders longer, did they actually get larger in diameter? So actually no, they only grow by their the boundaries that are there. So let's go through and let's look at, say, another feature real quick. So if I create, say, a cylinder right here on this click, now I have that cylinder number 7 there. I'm going to hide all of this, and with cylinder 7, when I use the grow and shrink command, you'll see that the only thing that changes is the length. Notice how the diameter still comes out to 19.117. Same thing with the shrink. So it's just the trimmed boundary edges that are growing. We can say they're extending or extruding. Great question.
Okay, second question. So the create dependency option was on by default. Why not leave it off all the time? Will anything go wrong if it's not turned on?
Okay, so the question is when we turned off the dependency under our tools options, why was it on in the first place, and is it okay just to leave it off? Well, the dependency was there under our options. When we come through and we look at that, the create dependency, this is all based off of inspection. So when we're doing multiple piece inspection, we need to have create dependencies there for functions inside of inspection. When we're worried or we're doing reverse engineering, we don't necessarily need to worry about that since we're just doing one part. So if this is all we're doing is reverse engineering, in this case, leave it unchecked. But if we're going to continue to do inspections, I would definitely leave it checked because that's what it was meant to do.
Thank you, Todd. It is all the time that we have for the questions. There are still some questions that are coming in. We're definitely going to get back to you by email. So this webinar has been recorded. It will be available on the Innovametric software website. Navigate to the support section. It will also be available on the Innovametric software channel on YouTube. And a reminder that we hope to see you at the PolyWorks Conference USA 2016 in Novi, Michigan on March 30th and 31st. So that's really coming fast. It's a 2D event. It will be filled with the launch of PolyWorks 2016, 4 technical workshops hosted by our application specialists, also some PolyWorks success stories by experienced users, the doctor's office, and much more. So we definitely hope to see you there. For all the details, please visit our website at innovametric.com. Our next webinar, well, it is scheduled for April 14th, but we are keeping the topic as a surprise. So no spoiler this morning, sorry. It's going to be a PolyWorks 2016 topic, that is for sure. So you'll have to stay tuned and join us on April 14th. Thank you for joining us this morning, and we'll see you next time. Bye-bye, everybody.